Good morning. I am Sunil Bhandari. I am working on 3D printing of thermoplastic composite diffusers for Culvert Rehabilitation. I am a PhD student at the Department of Civil and Environmental Engineering at the University of Maine. My advisor is Professor Roberto Lopez Anido. There are culverts across the state of Maine and the whole country that are deteriorating and failing. They either need to be replaced or rehabilitated. Replacing the culverts is expensive and causes disruptions to the traffic. Slip lining culverts is a way to rehabilitate the existing culverts. Slip lining extends the useful life of the culverts, but it reduces the diameter of both the culvert and the inlet. As a result, it reduces the culvert capacity. A diffuser outlet, which is a slightly flared pipe outlet, can be designed to increase the culvert capacity to compensate for the reduction caused by slip lining. The flared culvert diffuser has been shown to increase the culvert capacity by up to 40%. The culvert diffusers that are currently in use are made of fiberglass composite. The parts are so thin and lightweight that their design is governed by buckling. In the figure, you can see two diffusers. One on the left is a fiberglass diffuser at Thorndike, Maine. It is exposed to the environment. On the right is the fiberglass diffuser at Mattawamkeag, Maine. It is buried diffuser that needs to withstand loads from discharged water as well as backfill. The environmental resistance requirements for these two diffusers are also different. Since each diffuser has a unique geometry, each diffuser needs a different mold for manufacturing. It increases the cost and manufacturing time. Large-scale 3D printing technology enables manufacturing of complex-shaped culvert diffusers at relatively low prices, as costs in 3D printing is not dependent on the part complexity. 3D printing also does not require molds and the manpower that are necessary for traditional fiberglass composite manufacturing processes. For this study, we used the designs for Thorndike Culvert diffuser provided to us by our technical champion, Mr. Alexander Mann from Maine. The designed culvert was 1 inch thick and 102 inch long. The diameter at the inlet was 15 inch and the measured diameter at the outlet was 30 inch. Flared section starts at a distance of 24 inch from the inlet. 6 inch of the diffuser overlaps with the culvert outlet for connection with the culvert. 72 inches of the diffuser consists of a flared section where the measured diameter increases from 15 inches to 30 inches. The minor diameter remains 15 inches. PLA wood was used for this study because it is a commonly used material in large-scale 3D printing. The project plans to test the 3D printed diffuser at the site for 1 year and to collect relevant data for evaluating the performance of the diffuser. PLA wood was considered a suitable option for this purpose. Long-term diffusers would require different material. The diffuser will replace the existing fiberglass diffuser for a period of 1 year. The diffuser is 102 inch long and can be printed by large-scale 3D printer at the Advanced Structures and Composites lab in one piece. However, the decision was made to print it in 4 different pieces. The segmental manufacturing process can be used even for larger diffusers that have dimensions bigger than the build envelope of the 3D printer. As you can see in the figure, each of the 4 segments of the diffuser that need to be joined have a length of about 25.5 inches. 4.6 inches long lap joints are used to join the segments of the culvert. The segments will be joined using PlyoGrip 7770 urea thin adhesive. The 4 segments are expected to be printed in the last week of September. The estimated cost for manufacturing the diffuser is about $2,500. The cost of manufacture for fiberglass diffuser that this culvert will be replacing is $15,000. Roughly 6 times cost reduction is possible in this case using this 3D printed diffuser. We plan to monitor the performance of the 3D printed Culvert diffuser for 1 year and report the findings.